Welcome student. Before this we studied about nature of light, and in the nature of light we can determine the light can be travel in corpuscular nature by Newton theory, and light can be travel in a wave nature by Huygens theory. But for a long time we can determine dual nature of light. Now we can determine light as a wave. When light can be propagated in a medium, it can be travel in the form of wave. In which type of wave? That means we can study that light is an electromagnetic wave. Electromagnetic wave, that means for propagation of light material medium is not necessary. That means light can be travel through vacuum as well as medium. This can be determined or it can be studied in 11th science. Also, this when light can be travel in the form of electromagnetic wave, this wave also in a transverse nature. Transverse nature, that means light considered alternate crest and troughs can be followed by one another. That is, when light can be travel in a medium, we can determine alternate crest and troughs can be formed. That is, convex part is called as crest and concave part is called as troughs. And then we can determine light can be travel in a medium. It is electromagnetic wave as well as it is a transverse wave. That is, electric and magnetic field are perpendicular to each other and perpendicular to the direction of propagation of light, and the same type crest and troughs can be formed. When light can be propagated in medium, it not the medium is not necessary. That is, when light can be propagated in medium, the speed of light is depend on refractive index of material medium. That means when light can be travel, that speed of light is depend on medium. That is, if medium is denser media, the speed of light gives less. If media is rare medium, speed of light is rare. That means speed of light is depend of refractive index of material medium. Refractive index, refractive index is the ratio of speed of light in vacuum. We know that speed of light in vacuum is equal to what? C, and C is equal to 3 into 10 raised to 8 meter per second. Then refractive index of medium is the ratio of speed of light in vacuum to the speed of light in a medium. This electromagnetic wave, that is light wave, is a electromagnetic wave. And electromagnetic wave, the spectrum of electromagnetic wave we studied in 11th standard. This electromagnetic wave consists a spectrum of very small wavelength to very greater wavelength. Very small wavelength, nearly about 10 raised to minus 15 meter. That is femtometer to we can determine kilometer. That is, range of this electromagnetic wave is considered as from femtometer, that is very very small, to kilometer, that is very very large wavelength. Therefore, this electromagnetic wavelength are classified into gamma rays, X rays, infrared rays, ultraviolet rays, visible rays, also microwaves and radio waves, and this can be classified with increasing wavelength. We are human, that is human lights feel different colors rays in visible region, and this visible region is followed by nearly about 400 nanometer to 700 nanometer. That is, visible region can be formed by 400 nanometer to 700 nanometer. Wavelength of light is very small, therefore it can be determined unit angstrom unit. That is, 1 angstrom is equal to what? 1 angstrom is equal to, we can determine 10 raised to minus 10 meter. We also studied this relation in 11th standard. White light, which is studied or we seen in everywhere, This white light is a mixture of different color rays, and when this white light is incident on the triangular surface like as prism, this incident on a triangular surface, we have different colors, and this color is called as rainbow color. This color has 7 different color, and this color is split into from red color to violet color. Violet color have less wavelength, and red color have greater wavelength. Then we can determine visible region of this sensible for human eyes is ranges from red color to violet color, that is from say 400 nanometer to 700 nanometer. Okay, this refractive index of material medium is depend upon wavelength of light also. Then we can determine it for a same angle of incident, that is if white light can be incident on a uh, one's refractive surface of prism with same angle of incident, but it has different refractive angles of different color, that is red light has different refractive angle, violet light has different refractive angle, therefore we get different refractive index for different color. Okay, then we can determine for that this is the region of formation of spectrum of rainbow. Now we can determine light is a travel in the form of wave, and firstly this light can be travel in the form of wave determined by scientist Hygiene. Therefore now we studied about Hygiene theory. Hygiene theory consists there are two types of source of light. There are number of source of light around us. That sources of light are divided into two types. That is, one is primary source of light and another is secondary source of light. Primary source, that is source which emit light of their own, that is they produces their own light, they are called as primary sources. Example of sun, star are the primary sources. Then secondary source of light do not produce light, but they receive light from other sources, or they receive light from primary sources, that are called as secondary source of light. Okay, that is the example for moon, earth, we are also secondary source of light. This is about the primary source and secondary source. These primary sources and secondary source are useful in a hygiene theory. Hygiene theory also studied that when light can be travel in a medium, there are different wavefronts can be formed. Wavefront, wavefront means it is a locus. Wavefront means locus, where all the point of the medium to which wave reach simultaneously, and all points are same phase. That means we see wave on water. If we drop any stone in the water at the point of disturbance, number of ripples can be generated, and when this number of ripples can be generated, we see that water particle can be move up and down, and wave can be formed, and this wave is perpendicular to the water surface. If we can determine the phase of wave, the phase of wave means what? The state of motion of the particle at that point is the same distance and same point from the source. That is called as phase. That is state of vibration of particle of medium are same. That is same phase. Okay, that is locus of all points. Similar way, when light can be travel in a medium, the locus of all point having same phase at given instant of time, that is called as wavefront. The direction of propagation of wave is perpendicular to wavefront. That is, we studied that when wave can be travel on a water, wave propagate from point of disturbance to the for all possible direction, and this direction is perpendicular to wave surface. Okay, from that similarly wave can be travel in a medium. The speed of wavefront is moved from the speed of wave, that is wavefront also move with the speed of wave, and this wavefront carries light energy in all direction perpendicular to the surface. There are the water wave is one example of two dimensional wave can be formed. Here we can determine when light wave travel in a medium, the medium is a three dimensional wave can be formed, that is light wave is a three-dimensional wave. Sound wave is a three-dimensional wave, that is wave can be travel all possible direction, and this wave can be travel away from source and propagate in a three dimension. That types of wave is called as spherical wave. Spherical wave, if we studied that, these types of wave, if we studied, this is one sphere, this is another sphere, and this wave can be travel in the form of like this is one center, and wave can be travel away from the center of the, like this wave front we can determine this is the spherical, this spherical surface, this is a spherical wave, that is wave can be travel in a spherical direction in a three dimensional condition. Sound wave, light wave are the three dimensional wave. Okay, then from that we can determine there are types of wavefront. One is a spherical wavefront. We see now we can determine this spherical wavefront like as a, this is one sphere, this is another sphere, this is then long sphere. The wave can be travel from the center, and this center we can determine wave can be travel all possible direction. This is from center wave can be travel. This is the spherical wave can be corresponding to the diverging beam of light, and this is spherical wave frame. Light wave produces by light source travel in all direction away from the source, propagate in a three dimension. These spherical wavefronts are passing through all points having same distance from the source and having same phase. That is, this small sphere having all the points are reaches simultaneously at same distance and same instant of time. Then another sphere also have all points or all these sphere having same state of vibration, same phase, and they can be reaches at the same instant of time. That is called as spherical wave. Another wave, that is a plane wave. When light source is a very far distance, that is we can receive light from sun to earth, and distance between sun and earth is very long distance, this is very large distance, that is wavefront travel from, that is light can be travel from sun to earth. This is a spherical wavefront, that is we can determine it can be considered as plane wavefront. Because of what, this distance in a long distance we have this spherical wavefront is converted into plane wavefront, that is plane wavefront is a small portion of a spherical wavefront. But when light of source of light is very far away, we can determine this spherical wave is not seen clearly, that is we can determine light can be travel in the form of plane wavefront. Okay, then if we can determine here in plane wavefront, suppose here is a one plane, this is another plane, this is another plane, then light can be travel in the form of this plane wavefront. Okay, then cylindrical wavefront, if the source of light is a linear, that is tube like source or slit like source. This in the case of tube like source or slit like source, light can be travel, the wavefront of light is a cylindrical wavefront, like as a uh, light can be travel is the form of cylinder. Therefore it is called as cylindrical wavefront. Then from that we have hygiene principle. Hygiene studied that when light can be travel from one media to another media or one place to another place, it can be travel in the form of wavefront, and each point on wavefront acts like as a secondary source. That is, we can determine, suppose here we can determine spherical wavefront. The spherical wavefront, this is one sphere, light can be travel from this small point and it the spherical wavefront can be formed. That is spherical, this first sphere having each point is acts as a secondary source of light. For suppose this is next sphere, the first sphere is a secondary source of next sphere. The next sphere is a secondary source of their next sphere, and therefore we can determine this is the each and every point on wavefront is act secondary source of light emitting secondary light wave, and this light wave is called as wavelet. This wavelet is travel in all direction with same speed of light in the medium. Okay, and hygiene also studied that this new wavefront can be obtained by taking envelope of secondary wavelength. We can studied now with secondary wavelength. We studied different circles can be formed, and this the secondary wavelength traveling in the forward direction, not in backward direction. This is hygiene principle. Using hygiene principle, we study that how the spherical wavefront can be formed and also how the plane wavefront can be formed by taking secondary source of light or emitting secondary light wave. Okay, understood. In this part we studied that light can be travel in the form of wave and some part of hygiene theory. Okay,